You've probably interacted with visual AI more often than you realize. From unlocking your phone with your face to cars recognizing lanes on the road, machines are learning to interpret images in ways that support real-world decisions. That capability comes from computer vision, powered by advances in deep learning. Computer vision focuses on helping machines see and understand visual information. The goal is to take raw image data and turn it into insights, such as identifying objects, tracking movement, or recognizing patterns. A useful starting point is understanding how images are formed. Before an AI system can interpret an image, it needs to process how light interacts with objects and how cameras capture that information. Concepts like color, lighting, and digital imaging all play a role in shaping the data that AI models use. This is where foundational ideas from data science and signal processing come into play. Images are essentially data, made up of pixel values that represent color and intensity. AI models analyze these patterns to detect structure and meaning. You'll also encounter the 3 levels of vision. Low-level vision focuses on basic features like edges and textures. Mid-level vision groups those features into shapes and regions. And high-level visions interprets those shapes as objects, like recognizing a car, a person, or a traffic sign. Deep learning models are especially effective at this process. They use layers of neural networks to progressively learn more complex features from images. Early layers might detect edges, while later layers recognize full objects. Let's connect this to a real-world example. In self-driving systems, cameras capture the environment in real time. Computer vision models analyze that input to detect lanes, pedestrians, and other vehicles. Each frame is processed quickly, allowing the system to respond safely and efficiently. The Computer Vision Basics course, offered by the University of Buffalo on Coursera, covers all of these concepts and introduces the mathematical foundations behind these systems. Topics like linear algebra, calculus, and probability help explain how models process and transform data. These concepts support the algorithms that make visual recognition possible. You'll also gain hands-on experience working with tools like MATLAB. Through guided exercises, you can explore how images are processed, how color channels are separated, and how features are detected. Another important area is understanding the broader ecosystem. In healthcare, computer vision can assist with analyzing medical images. In retail, it supports inventory tracking and customer insights. This course is designed for learners with some technical background. Familiarity with programming concepts, basic math, and 3D coordinate systems helps you move through the material with confidence. You'll move through modules that cover the fundamentals and history of computer vision, how images are formed through light and color, the 3 levels of visual processing, the mathematics that power computer vision systems, and by the end, you'll have a clear understanding of how machines interpret images and how those systems are built. You'll also gain experience applying mathematical techniques to real computer vision tasks. If you want to explore this further, the Computer Vision Basics from the University of Buffalo offers a practical introduction to the field, combining theory with hands-on exercises. Visit Coursera to enroll.